Hello, Mario. 2019 Engineering Maths Weekly Quiz 7 Review. Hello. Welcome. Quiz 7. Well, the way that the program's gone this semester, Quiz 7 is a review actually of quizzes 5 and 6. So there's no new material being introduced in this quiz. It's just material that has been gone over in quizzes 5 and 6. And we'll move on to calculus differentiation in quiz 8 coming up. So something to look forward to. So that's how it is. This lovely scene at the back here is a New Zealand surfing break. If you can tell me where it is in the comments below the video, you get one free spin of the vending machines in the hub at Wintec campus. So to be able to retrieve that stupendous prize, of course you must be a student who attends the Wintec campus and is able to find me. So yes, one free spin for commenting below the video. So let's get on with the show. And here we have quiz 7, and a bottle of milk is left out of the refrigerator, and its temperature will increase. Obviously it's cooled in the refrigerator, it'll get hotter. Its temperature will increase following this equation here. And initially your first job is to find out what is the initial temperature. So that is the temperature when T equals 0. Oh, that looks a bit fat there on the old pen size there. Let's cut it down a tad to that. When? Perhaps not. So when x equals 0. And we put a line under that. So when x equals 0, T equals 22 minus 18e to the negative. Now k is just a constant. And t, oh, now that's not t equal to 0. That's not x equals to 0, that's t. Where did he get that x from? Well, it's t. So it's when t equals 0, negative k, and the t would go in there. 0. And as we know, anything to the power of 0, be it e, 100, negative 47, anything to the power of 0 equals 1. And 1 times anything, of course, is there. So now we're going to get t equals 4. 4 what, you might ask? Well, degrees centigrade, of course. Degrees Celsius. T equals 4 degrees C, and that's your answer. Yep, that's the answer that we're looking for. So, done. All done. Just reaching for my notes here. Okay, that's all done. Now, so that's A. Part A done. Let's do part B. A plan of action is necessary here to do part B. So if the temperature of the milk is 10 degrees Celsius after 40 minutes, how long does it take to reach 15 degrees Celsius. Ooh, so, yes, well, looking at that, we don't know what K is, but they've given us a little bit of information that would enable us to work it out. So we can say when T equals 40, when T equals 40, that's little t, minutes, that's time, big T, temperature, equals 10 degrees. Okay, so right, so now we can fill in some stuff. So we've got, using the formula, T is 10. So therefore we've got 10 equals 22 minus 18 e to the negative k, which we don't know, and little t, which is 40. Just filling that in there. Put a bracket around it, like that, and a bracket around that there, so that we know that that was there. All right. So, well, first off, let's subtract 22 from each side. So that's going to be 10 minus 22 equals negative 18 e to the negative 40 k. Alrighty. So now we've got 18 times there. So let's divide through by 18. Both sides, of course. You do to one side, you must do to the other. So we just put those over 18 like that. And a line there over 8. Oh, negative 18. Negative 18. Wherever possible, try and deal in positives, because negatives, it's very easy to leave that negative off. So, what have we got there? Well, we've got 10 minus 22 is negative 12. Negative 12 over negative 18, which actually equals 3. 6 goes into that 2. 6 goes into 2. And, well, negative 6 actually, and 3. So that equals 2/3. And then that equals negative 18 over 18, just gives us e to the negative 40k. So what now? What now? Well, I'm going to go in search of my calculator. Here it is here. Yeah. Does it appear? Oh, there it is. And I'll just bring it over here, and I'll just drop that out of there, and there it is. Now, the reason I bought this here is because if you look on your calculator for the log function and the e to the x, you'll see that they're on top of each other. Now that tells you that they're inverses. One undoes the other. So what we do here then is we go ln 2/3. So we take the log of both sides. Taking the log of both sides. Now that'll undo the e. So we've got log of 2/3 equals negative 40k. Okay. Negative 40k. I only want 1k. So we divide through by negative 40. And that will give us, oh, well, we can do that, can't we? We can go here like that. Negative 40 equals k. Okay, negative 40 equals k, and k equals, all right, k equals, get my calculator out. And so what we can do is we can go like that, and then we can go log, and then we can push that again, 2, drop down, 3, and close the bracket. Oh, and then we can make that negative 40 equals, oh, didn't like that. I think that might be, oh dear. I see all sorts of problems here. I think we'll start again. So, just getting it right on the calculator, there and there. Oops, no, delete. Right, ln log of 2/3. Close the bracket, then drop down to there, negative 40 equals 0.0101. Now I'm just going to move that over onto my second screen where I'll still be able to see it. 0.0101. Yeah, I'll just bring that back. You can see there 0.0101. All right, so that's given us K. So we want to know when the temperature, that's the big T, will be equal to 15. So that's when 15 equals 22 minus 18 e to the negative, now we know what k is, 0.0101 t, and that's what we're trying to find. That's what we're trying to find. So once again, we subtract 22 from both sides. And that gives us 15 minus 22 equals negative 18 e to the negative 0.0101 t, and then I'm going to divide through by 18 as we did above. I'm going to divide through by negative 18. And then I'm going to take the log of both sides as previous. So we're going to get now negative 15 over negative 22 is negative 7 over negative 18. Yeah, negative 7 over negative 18. And we're going to take the log of that. Okay, now the negatives will cancel out. Okay. Oh, no, they'll become negative 7 over negative 18 equals, and we took the log, negative 0.0101 t. So what we do now is divide through by negative 0.0101, and that equals t. I'll put that over here. Negative 0. So we're dividing both sides by that. And if we work that out, we get t equals. So let's get the calculator back. Here it is here. Right, all clear. So we've got log again, ln. Now it doesn't matter. We could go negative. Delete that and put that in there. Negative 7, and we could use it. We don't have to. I mean, I would just put 7 over 18, but it doesn't matter. We can do negative 18, and then we can move on from there and close that out. So what I've done is I've forgotten to put that there. So that's going to be divided by, I'll do it that way, divided by negative 0.0101. Okay, or over, that's right, and that equals 93.5. Oops. 93.5 minutes. Okay. All right. So now that's it. That's it done. Okay. 93.5. So in terms of marks, probably that wasn't how that was supposed to be. It's supposed to be that colour. 2 marks for that, and 1 mark for this here. Gives you 3. Okay. Right. Now, this graph here. All right. How are we going to do that? Right. Well, first of all, it's in the form y equals a sine bx plus c. So just we'll get back to red here. That there's equal to a, just quietly, and this here's b. In terms of the things on our formula sheets, and that's c. Very important to note here that this use radians here. So this 1 is a radian. All right. So let's have a look at A. So, oh, sorry, not A. That's going to be P. So when P equals P, oh, that's the what we're going to be looking at. Oh, undo that. P, and that's going to be when x equals 0. Okay, so that means that y will equal 1.6 sine 2 times 0 plus 1, which equals 1.6 sine 1. Now note that that's 1 radian. Okay, and so we'll get our calculator here. So here's our calculator here, and we'll make sure that it's in radians. Shift mode 4. Okay, just check that again. Shift mode 4. It should appear up in here as, yeah, so I think you can see there the little radians thing there is highlighted. Right click. Yes, I can see. Oh, it's sort of hard to see really, That's there anyway. So, right. So now, let's get this all sorted. We do need to, I think it's best to keep these in 2 decimal places, but sometimes we need to keep it in 4 just so that things can be maintained a little later on. So, all clear, and let's go 1.6 times sine 1 equals, and that equals 1.35. Okay, so x is 1.35. So this point here, P, that's going to be the point 0, comma, 1.35. Okay, so that's when x equals 0. Now here at Q, this is when y equals 0. So we've got Q, and we've got y equals 0. I like to underline those as their sort of conditions. Like that. That's when y equals 0. So therefore we get 0 equals 1.6 sine 2x plus 1. All right. Yes. All right. So what we get is if we divide through by 1.6, we can put that here. And that we can see there that 0 equals sine 2x plus 1. And sine to the negative 1 of 0, which is the inverse, will equal 2x plus 1. So let's get our calculator out, and we can see that no, all clear, all clear. Sine to the negative 1. Oh, that's not. Sine to the negative 1 of 0 equals 0. So therefore we get 0 equals 2x plus 1. And 2x plus 1, Therefore, we subtract -1 off both sides, and we get 2x equals -1. Divide through by 2, and we get x equals -0.5. Now that's -0.5. X equals -0.5. So this must be this point here, because that's in the range. So that's -0.5. I mean, that's the answer we've got when we solve that, and that must be that solution there. But we want this solution here for Q. And as you can see, if we take the from there to there, that starts there, that's one period. So we need to add half a period there. Okay, so, and that what's the period? Well, that's P for period from our formula sheets equals 2 pi over B. Oh, that could be a little bit confusing there. So I'll put in here period. Equals 2 pi over B, which equals 2 pi over B is 2 in this case. So the period of this graph is pi. And that little piece in there, that's pi by 2. So we must add that on. So x can equal -0.5 and -0.5 plus pi by 2, which equals -0.5 plus pi by 2. I have to go to here, and that equals, on the calculator, negative, oh, all clear. Or you can just go -1/2 plus pi by 2 equals 1.7008. No, I've got that around the, read that wrong. 1.0708. .0708. So this point here is going to be 1.0708, 0. Okay, so yeah, just to check that out, let's bring our calculator back here and let's just go all clear. 1.6 times sine 2 times 1.0708 plus 1, close the brackets, equals negative 1.1754256, okay, times 10 to the negative 5. That's a very small number. Shift mode 6, and you can see that that's a very small number, close to 0. So that's confirms that answer. All good. All right, which leaves us now with R to find, and I'll start R over here just to give me plenty of room. R. Now at R you can see that this is the amplitude here, and that is A. So R is when, and it's negative, when Y equals negative 1.6. Okay, so that's the amplitude, isn't it? Yes, it's got to be. Yep. All right. So I'll put that in there. So we get, just writing that down, we get 1.6 sine 2x plus 1 equals negative 1.6. And if we divide through by 1.6, we get sine 2x plus 1 equals negative 1. And so then we can go sine to the negative 1, negative 1 equals (2x plus 1). And if we get our calculator out, we'll find that all clear. Shift. Sine to the -1, -1 equals -1/2 pi. So we get negative a half pi. Okay. Negative a half pi there. What's happened here? Negative 1/2 pi equals 2x plus 1. So, minus 1 from both sides. Gives us negative a half pi minus 1 equals 2x, and then we divide through by 2. Divide through by 2, and we get, I'll just put a little line in there, x equals, so we'll put it 2 over here, negative, well, that's pi by 2, negative pi by 2 minus 1 all over 2. Okay, and that equals, alright, let's go to our calculator here. Negative pi by 2, so that's already there. Minus 1 equals, and then we divide that by 2, divide 2 equals negative 1.2854. Negative 1.2854. But, alright, that is here. That there is negative 1, no it's not, it's here. That there is negative 1.2854. That's in here to give that put there. That's not the one we want. We want this one over here. Okay, and so that's well, from there to there is a whole period. That's the period. the graph starts there and then it's starting here again. So that is one solution, negative 1.2854. That's one solution, but we want another solution, which we've found up here, is our period is pi, which is pi minus 1.2854. Pi minus 2854, or minus plus pi, doesn't matter. So that's equal to negative 1.2854, and then a recurring one, which is, so get our calculator out here, and well, let's just add pi plus, I'm hoping that's what we've got to do, yeah, plus pi, and that gives us 1.8562. One point 8.562. So that means that R is the point 1.8562, that's its x coordinate, minus 1.6. So that's interesting. Let's check that out. All clear. So if we go to our formula and go 1.6 times sine 2 times 1.8562 plus 1, I think this will work, plus 1 equals 1.6000 negative. So that's all good. Yeehaw. Feels good when you get them right. So how should we possibly be recording these? I've shown them on there on the graph. That's probably a little bit untidy. So perhaps you possibly could put the answer here for this one, 0 brackets 1.35. Indicate that's the answer. Here you could put 1.07, 0, indicating that's the answer to that one. That's P there, that one. This is Q. And then 1.86 minus 1.6 that is R. Okay, so that's that one done. I'm going to have a little bit of a rest now. Well, actually, it's 11:30, so I'm going to drive in and start getting ready for class at 3 o'clock. So I'll finish off the second page this evening when I come back. So, yep, let's, well, we can turn off layer 1 here and, oh, there we go. And we can get ourselves ready for solving question 3, which seems to have some little bit of writing on it there. I don't quite know where that came from. I don't think we can undo that. Ah, yeah, so we'll have to persevere with that. Well, there is an eraser here, but I think it tends to erase everything, including the grid. Never mind. Rather than undo stuff. So, yeah, but that's all good. So, we'll see you later on this evening. Cheers. Hello, I'm back, and we're going to do question 3. Now, before we start question 3, I seem to have got this big pen here. I don't know where I've got it from, but anyway, I think it's probably all right. So, just to make it perfectly clear, for this one, we were dealing in radians, and I should be using the pen, not the mouse. That's better. Okay, so just using the smooth draw program. We're using here radians. My pen size, I was going to have it at about 7 there, and the ink flow at 100. And I need to go like that and then do it, I think. So it's, I think, around about 5 or 6 perhaps. Yep, that'll do, and we'll just close that up so that doesn't change. There we go, radians. Right. So what we do here is, to deal with this here, we substitute. So we, red pen, we let u, so I'm using this variable u, equal 2t plus 0.2. Now, if u equals that, let's see what t equals. We'll find out what t equals. So first of all, I'm going to minus 0.2 from both sides. So we get u minus 0.2 equals 2t, and then we're going to divide through by 2 both sides, and so that gives us u minus 0.2 equals 2t over t. So just putting the t on this side, so just swapping the side, t equals u minus 0.2 over 2. Okay. So up here is the range of t. T ranges from 0 to 2 pi. But now we've introduced this other variable, u. So what's the range of u? So when I'll just I think I'll do a different color for that. Oh, I've gone a bit far there, I think. Yeah. Okay, I'll do green here. So let's say when t equals 0, okay, so we'll just have a look there. When t equals 0, u equals 2 times 0 plus 0.2, which equals 0.2. And when t equals 2 pi, so that's the other end of the range, so when t equals 2 pi, we can see that u equals 2 times 2 pi plus 0.2, which equals 4 pi plus 0.2, which equals, although we possibly won't need it, let's see here, all clear, 4 times pi plus 0.2 equals 12.77. Equals 12.77. So if we were to look at the range of t of u, we've got the range of u for this equation is 0.2 less than or equal to u, less than or equal to 12.77. Alrighty, so that's our range for u. Right. Okay. So we've got a range for u. We've got a formula here for t in terms of u. So that's a formula for t. And we've got a formula up here for u. Well, very well. So now we can rewrite the equation. Let's write the equation. I think we'll go back to red now because this is... so we can rewrite the equation 3 sine u 3 sine u equals negative 1.5. Okay. And so then we can say that let's divide through by 3. Divide through by 3. And so we get sine u equals negative 1.5 over 3. Negative 1.5 over 3, which equals negative a half. And just to finish this off, we can then say sine. So we can use our inverse sine. Sine to the negative 1, negative 1/2 equals, and we can go up to our calculator now, and so we can go shift. First we must make sure that we are in radian mode. Okay, 4. So I've done that, all clear. Shift mode 4 for the radians. Okay, so now let's go shift sine to the negative 1, negative 1/2. We could put 0.5, but I decided I wanted to do it this way. And there, and close the bracket, equals negative 1/6 pi, which we can write as negative pi by 6. Oops, it's not coming out so well, is it? Negative pi by 6, which equals negative pi by 6 equals, let's see what that, on our calculator, we just push this button here, negative 0.52, negative 0.52, negative 0.52, or negative pi by 6. Okay. And so that's, u here. u equals sine to the negative 1/2, and that's pi by 6, which is negative 5.2. Now we can see here that for u, that's outside the range, so that's not inside the range, so that one's that's not going to be much good to us because it's not in the range of u. Okay, I'm just gonna. So it's not in the range of u, so that's not a solution because it's not in our range. So now what we have to do is get solutions in the range, and we know we're dealing with a periodic graph. So what we can do now is we can, we can go to our formula sheet, and on there it gives us this formula for sine to the negative 1, which is x equals n pi plus negative 1 to the power of n theta, or the angle, the solution. I think that's what it is. In this case, oh no, in this case we'll go, it'll be u. All right. So what we've got to do is set up now, we set up this little table. So we have n, so we'll look at the different values of n. So the table comes across the top like that. So n, we've got 0, 1, 2, 3, 4, and 5. Now I know I've prepared this at home, so now in here we've got u, so this will be what u is. And remember, this is pi here. I haven't got that drawn very well. N pi, and then over here will be x. Well, in this case, t. Okay, so this here is u. Oh, now what have I got? How have I got that? I've got that wrong. So we're dealing with u. Solution that's for u will be n pi, yeah, this solution that we've got down here, this 0.5, 0.52. Okay, so u equals, oh, that'll be u there. All right, and this over here will be t, our answer, because that's the one we want, t here. All right, and this is u, and that's, these are the different solutions of u. So here's 0, so here we're going to have 0 pi Okay, 0 pi plus -1 to the power of 0. Anything to the power of 0 is 1, times u, which is negative 0.52. Or I might just show that as pi by 6. I think that helps our cause a bit better. Okay, negative pi by 6. And then over here, we've got t equals, because t is what was our variable, and that's going to be u minus 0.2 minus 0.2 over 2. Okay, so for this one here, now I've already gone to the trouble of working out. I've already gone to the problem of working this one out. We know that's outside the range already. That's 0.52. But anyway, we'll just check that out on the calculator. So, okay, so u is negative. Oh, okay, that equals. Oh, I've run out a little bit of room there. Equals negative pi by 6. That'll be 1. So that's equal to negative pi by 6 in there. And so if we put that in here, we've got negative pi by 6 minus 0.2 over 2 equals, and we'll do that on the calculator here, all clear. So negative pi by 6, so negative pi by 6, negative pi by 6, minus 0.2 minus 0.2 equals, and then we're going to divide that by 2. Divide 2 equals, and that gives us 0.36 minus 0.36, and I'll put that up there in red. Okay, minus 0.36, but that's no good because that's outside the range. Outside of the range, no good. Okay, so we'll cross that one out. Okay, so let's look at the next one. So now we've got 1 pi, okay, n equals 1, plus negative 1 to the power of 1 is negative 1 times pi by 6. So that's equal to pi it's negative pi by 6. So that's negative 1 times negative pi by 6, which equals pi plus pi by 6. Okay, pi plus pi by 6. That's right, because that's negative 1 to the power of 1 times negative pi by 6, which is plus pi by 6. So now we're going to feed that in here. And so, well, that equals, if we're dealing in sixths of pi, that equals 7 pi over 6. Okay, 7 pi over 6, which is 1 something pi. And we can see here that that's going to be in the range that's in the right range there, 7 pi by 6, right. So now we're going to go over here and we're going to go, so that's seven pi by 6 minus 0.2 over 2 equals, all right, so let's get our calculator going here. So all clear, so let's go, let's put that there. Okay, and then again, and up here we're going to go 7 times pi by 6, 7 times pi by 6 minus 0.2 all over 2. Equals 1.73, and that's a good one. 1.73. Because that's in the range, so that's for t, and the range for t is 0 to 2 pi. 2 pi here is 3.14, around about 6.28. Okay, so that's in the range for pi. All right, so now we're on, now we're going down here, and now we've got 2 pi and then we've got minus 1 squared, which is going to make that positive, times negative pi by 6. So that's going to equal 2 pi minus pi by 6. And 2 pi and 6 is 12 pi, so that's going to be 11 pi by 6. No. I didn't do too well with this table. So that equals 11 pi by 6. So over here we're going to have 11 pi by 6 minus 0.2 over 2. And if we go back to our calculator, yes, we should be able to change that there to 11 and push equals, and that should give us 2.78. Okay, so that's going to the red one here. .78, and then this one here is going to be right, this is going to be 3 pi minus 3 pi times plus minus 1 cubed, so that's going to be negative. That's going to be negative, and that's negative pi by 6. So that's going to be equal to 3 pi plus pi by 6, because the negative, so that's 3 pi plus pi by 6, which is going to equal 3 6s are 18, 19 pi by 6, 19 pi, 3 6s are, yes, 19 pi by 6, 19 pi by 6, so that's going to be pi over 6 minus 0.2 over 2. Okay, which is so that one's 7 pi. 2 pi minus the 3 pi, yeah, that's 9 pi, 19 pi by 6. And that's going to equal, so we can change that to a 9 and equals 4.87. Okay, 4.87. Now over here, now we're going to go over here, and so we're still within range, 4.87. Our range is well, 6.28, so let's go 4 now. So we're going to get 4 pi plus negative 1 to the power of 4, which is going to be positive. Times minus pi by 6. So that's going to be 4 pi minus pi by 6. So 4 sixes, that's going to be 23 pi by 6. Pi by 6. So then we've got 23 pi by 6 minus 0.2 all over 2. So that's 23. So we can see a pattern here. We've got 1 pi plus 6 gives 7 pi, plus 4 gives 11. 0 pi here, plus 7. 7 and 4 is 11. 8. Oh, perhaps we haven't got a pattern. 4, 11. Okay, it's not quite the pattern I thought it was. So we got 23. Yeah, all right. So there is a pattern there. I just can't see it off the top of my head. So let's go back to our calculator and let's flick that back there to 23, or is it 20? 23. 23 equals, and that's 5.92. Oh, we want that in red. This smooth draw program's free, by the way. 5.92. If you want to use it. Okay, now this next one here is going to be 5 pi. Oh, still haven't got it. 5 pi. Okay, plus negative 1 to the power of 5, so that's going to be negative, and that's going to be negative pi by 6, which equals 5 sixes are 30, plus, so that's going to be 31 pi by 6. Okay, and we can see that 5 pi plus pi by 6 is going to exceed our range for u, because our range for u is 4 pi, so 5 pi is definitely going to be outside the range. And yeah, all right, so there we have it. So therefore we can now say that t, so that's going to be outside the range there, isn't that one? T equals 1.73. Remember, these are radians. 2.78 4.87 and 5.92. Okay, and so just want to do a little check here, and let's see how one of these goes. So let's say t equals 1.73. I'm just going to get the calculator now. Go to here. All right. All clear. Okay. I just might make this here a little bit bigger, actually. This calculator. Oh, that's better. Just a little bit bigger there. Okay. All right. Oh, can we see that all? All right. Now let's just have a quick check here. So what we want to do is we want to come back, 3 sine 2 times 1.73, okay, plus 0.2, close the bracket, equals negative 1.486. So we could probably do a few more decimal places and would be all right. So 1.73, that's all good. 2.78, so let's see how that go. Let's go there with that one. Delete. Times 2.78 equals, there, negative, that's all good, so it's equaling negative 1.5. So this is a good bit of a way of checking your answers relatively quickly. 4.87. Yeah, well, it's the same as the other one, so yeah. All right, and yep, and the other one would be 5.92. Oh, 1.50, so that's come out a little bit better than the others. And yes, so there. So Leah, just to recap a little bit on that one there, because that's quite a process there. So first of all, we substituted u in for we'll just better just say over here that this is from the formula sheet. Oops, what's happened there? Okay, so this here is from sort of from the formula sheet, but I've adjusted it for this situation. So u equals n pi plus negative 1 to the n u. Okay. So just that there. So u equals n pi plus negative 1 to the power of nu. So I've adjusted it for u. On the formula sheet it might be for a variable x, shall we say, or whatever, so we can adjust it. But in our case here, we use t and u. All right, and so they're all there. So let's This here can possibly, I don't know why I've written that there. Didn't follow through with that, did I? So I'll just go there like that. And we'll just edit clear. Oh, there we go. It's also clears the background as well. Never mind. Okay. Alright. And here's back to the felt pen. Alrighty. Okay. So, yes, so we substitute for U, and we also work back over here for T in terms of U. Then we work out the range for, we've got the range for T given to us, so this is the range for U. Then we solve for U, and then we get the various solutions for U because it's a periodic graph. And then that gives us 4 answers there that are within the range, which is 0 to 2 pi. And we know that this one here at 0, negative there, so that's not going to fit. So that's got to be the first solution there, and there, and there, and then the next solution's too big. Alrighty. So let's go to the next question. Wow, that took quite a bit of time, that one. I haven't got the time here on my recording software. Okay, all right, so let's have a look at this one. So a ball kicked at an angle of 35 degrees above the horizontal, travels at 25 meters per second. Find the vertical and horizontal components of the velocity. Express your answer to the nearest centimeter per second. So the best thing to do here is to draw a diagram. So here's our ball right there. Okay. So there's our ball. Alright, I'm going to draw the ball there. So there's the ball, and we'll go for the center of the ball, and then we're going to draw a line up there 35 degrees above the horizontal. And, well, we're going to make a right-angled triangle there like that. So there's our right angle. There's our ball here. Okay, it's a tennis ball. Okay, so now this is 35 degrees. Remember, it's degrees. Yes, and our calculator's probably still in radians, so don't forget to put it into degrees. That's 35 degrees, and it travels at 25 meters per second. 25 meters per second. Okay, now one of the things that we use in trigonometry is SOHCAHTOA. SOHCAHTOA. SOHCA with an H. TOA. 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 Okay. All right. So if we look here, we've got a 35-degree angle. So that means that we can find the sine of 35, we can find the cosine of 35, and we can find the tan of 35. This is a right-angled triangle, and this side here is the longest side. The side opposite the right angle, it's called the hypotenuse. And I'm not going to write it in there in full because I usually get the spelling of it wrong, but that's the hypotenuse. Okay, now this is the 35, so the side that the angle looks at, that is called the opposite side. Opposite. So I'm going to call that the opposite side. And the side that with the hypotenuse forms the other arm of the angle, that's called the adjacent. That's the adjacent side. Okay, so what do we want to find out? Well, we know the hypotenuse, that's 25 meters per second. Boom. And what are we trying to find? Well, we're trying to find the opposite. There, that's the vertical. That's our vertical component. And we're trying to find the adjacent. And that's our horizontal component. So, quite simply, well, what we can do if we want to cover everything off, we can draw one of these little triangles here. And we can go S for sine, opposite, hypotenuse. Okay. So, what do we want to find? It's not working out quite what I wanted. Okay. And we've got another one up here. Oh, I've got that round the wrong way. I'll just put that there. Sorry, I just did that around the wrong way. So we've got a line down there. So we know that sine equals the opposite over the hypotenuse. Okay. Sine equals opposite over hypotenuse. Like that, in one of these little triangles. So if we want to find the sine, we take the opposite and divide it. But we know the sine and we know the hypotenuse, so we want to, what you do is you just cover up. If you cover up the one you want, you get sine times hypotenuse. So therefore we're going to go sine 35 times 25 equals. So we do that on our calculator. But first we must go all clear, shift mode, and we go to degree mode, which is 3. Okay, so we're in degree mode now. Right, so let's go. Now, just before we do that, the hypotenuse is the longest side. So at this point here, we're going to work out the, we're using the sine. Okay, so that's going to work out the opposite, which is the vertical component, all right? So that's the sine. It's going to work out the opposite there. So it's sine 35 times 25, and that's 35 degrees. Now, there's an expectation then that the opposite will be small. smaller than the hypotenuse. So always pays to fix that, just to have that in mind, okay, as like a sanity check. Sine 35, close the brackets, times 25 equals 14. Okay, and that's going to run away. 14.34. Or 14.339 actually. Okay. Okay, 14.3394. I'll put it to 4 decimal places. Now the question says, express your answer to the nearest centimetre per second. So this is meters per second. We want the answer to the nearest centimetres per second, so 14 metres, 30 decimetres, and 3 centimetres. Well, not 3. Well, that's the centimetre position there. So we need to round it up. So it says to the nearest, that there. So that's express your answer to the nearest centimetre per second. Well, you could do it like this, 14.33, and then you could 334. Three, 4, and that's 2 dp. And that's the vertical one. So let's put that there on our diagram. 14.34. That's what we want. All right, so now we do this one here. You don't have to do these, but these are okay. So we want to do the cosine K A over H. So these little triangles make the calculation easy. So all you have to do, what do I want to find? What do we want to find? When do we want to find it? So you cover over the A, and you can see that that would be cos 35 times the hypotenuse. If you wanted to find the cosine, that would be the adjacent divided by the hypotenuse. If you wanted to find the hypotenuse, it would be the cosine 35, the adjacent divided by cosine 35. All right, so we want to find the adjacent, so that's just cos 35 times 25 equals, get our calculator out. Okay, so we can actually just, if you want to just go back here and delete cosine equals 20.4788. 20.478. So we want to round it. So we want to round it at the second, which is there. So that equals 20.48, or approximately equal should be, to show that you've rounded it. Okay, 20.48 2dp. Okay, and underline that. And, well, we'll write it in here. 20.48 meters per second. Meters per second. Meters per second. But rounded to the nearest centimetre. So see how that stuff that you learnt about the metric system way back when comes into play now. So there we have it. The quiz 7. Some quite significant questions there. So not only do you need to get your head around those, but you need to be able to do them quite quickly. Obviously, a lot quicker than I perhaps explained them there, I guess, in some ways. But yes, it's a lot easier going if you're just doing it in exam conditions. So speed can become an issue. All right, so don't forget, you know, if you're the first one to tell where the famous break is here, remember this, where this famous break is, put it in the comments below the video. One free spin on the vending machines at the Rotocarry Hub. Ooh, what will I get? Oh, I won't get anything, you will. But yes, all good. So, cheers. Have a wonderful day, and well, we'll see you next week.